Hey guys, welcome back to AI with MJ. Currently, I'm doing NeetCode 250, and this is problem number 5 from that list. I'm gonna be pasting the question here and then start a timer for 15 minutes. I do not find as such like variance for this question, but this is like a very common interview question and it has multiple solutions. So I'm gonna go in depth, like in trade-offs of which solution is better and for what reason, and then at the end decide which solution to actually implement. Like in the past 3 months, this question has been asked by Google at 41 times and about 24 times in Meta. So let's get started and yeah. So this is the question and so write a function to find the longest common prefix strings amongst an array of strings. And if there is no common prefix, return an empty string. Okay, so here the input is strings in form of list, and we have to find the common prefix in every string in a list. Okay. And if there is no common prefix, return an empty string. Got it. So in this case, can the output input be empty? Also, in the input, only one string is empty, and white spaces. Um, is it only lowercase characters and size of strings? Also, length of size of like strings, which is the list, and length of each string. And it could be like any other character as well, like alphanumeric. So, and yeah, I think those will be a few questions that I would ask. And then, can the input be empty? Yes. So, if suppose string is equal to this, then the output would be just an empty string like this. And yes, then we just return an empty string. Actually, this would just be an empty string without the list. So, for example, if this is the string that's given, and if this string is empty, then we will just return an empty string because there is no common prefix, no white spaces for this scenario, and for now, only lowercase. Size of the string, size could be like 200, and the length of each string would be from 0 to 200. Okay, so one thing that comes to mind is we just like stack each other interview with internet, and then go over the solution in the string. That would be like a vertical scanning solution where what we can do is we can have, let's say this is our string, and we have an I pointer which starts at the start of this string, and the outer for loop will only be length of string at index 0, and then I will continue for until the end here, and this inner loop will go and check every character. So if I was here, then it'll, sorry, this is not I. This would just be S. Like let's say we're doing S. This is what the whole S is. And we'll start S from here because that's what we consider. And then this will check for every I is equal to I is equal to I. And if suppose here there was a J, then it would just like return until that. And right now there is no prefix, so would just return that. So in this situation, we are doing l- like one for loop for m. Like let's say n is the length of string and m is size of the string, like this whole string, and the time complexity here would be around O of m by n, and space would just be O of 1 because we're not using any extra space. Um, so that is one solution. And then the other solution could be a try. And how we build try is we have a root node then, and then the try would just go and look up in the tree if every word is similar. So we'll have a node for I, and then for the first word, we will create the whole tree, whole try. So I, N, which will have D, E, R. And then we can set up try in such a way that this, when you potentially go down for like, let's say internet, then we will only stop like if whenever the node is different, and then we move on. And this would be like a space complexity of O of N because potentially we are storing like the whole, actually O of M because O of N, the shortest string. And for time, it would be the same O of N into M. So let me try to do like both the solutions coded up and then we'll go from there. The first solution we can do define um common prefix, common prefix, and it'll take in strings, which is a list of strings. And the output is again list of strings, or it could just be a string actually. And then we have to handle the base case when it's empty. So if len of strings, actually one would be like if len of string equals 1, then that is the answer. So we just return strings at whatever is at index 0. But if like let's say len of strings at index 0 equals 0, then we just return an empty string. Okay, and then the other thing that I mentioned that we'll have an I pointer. So for I in range, len of strings at index 0, that is like our starting comparison. And then we'll have another like index which we can just start from, let's call it j, and it will go from range of 1 to len of strings. Yeah, and then we will check that if I is equal to len of strings at index 0, or like that means it has passed that and that it's not possible, or if the characters are different, or strings at index j and at index I of that is not equal to strings of if it's not equal to string of 0, which is the first index that we were at index I, then we just return the string from um, till I. So we could just do till I. So it'll go from 0 till I. And yeah, and if that is not the case, then all of the strings are similar. Oh, actually, one question would be, what if all the strings are similar? Then just return the first one. So if this does not return anything, then we can just return strings at index 0, because that is what all the strings are similar. And yeah, that would be the solution. I could do a dry run quickly. So let's take this as well. And here we have I, which would go from, I will go from 0 to 1, 2, 3, 4, 5, 6, 7, 8, 0 to 8. And when, let's say, I is at 0 right now, and then j will go from 1 to the length of string, which is 3. Okay, so, all right. I is at 0 and j is at 1. Okay. And then, which is this interval here, I here, j is at the whole index. Then it'll check if I equals length of string at 0. No, which is 8. So it will continue. Then I will be shifted here. Then it will also check like if the j pointer at ith index, which is 0. So it will check like, okay, wait, string at 0, comma 1 is equal to string at 0, comma. Okay, this is for this part, and then j is currently at 1, so 1, comma 1, and I is also 1. Okay, so it'll check this for every character, and if our j pointer is here, then I will check for each individual word, and if not, it'll just return back. Okay, I think I only have like 1.5 minutes left. So how the implementation for tree will go is, let's say we are doing try node. So we can just initialize class. Oh, what? What is going on? Okay, so here we'll have a class try node, and we can just initialize it with the children. That's all we need. So init self, we're not returning anything. And we can just do self dot children, which could be like a default dict anyway, to store all the children. That's the node. And then we'll have a class tree try, which will take care like of insertion and then the lower, like the largest common prefix. So we'll have define like insert into the tree, and we'll also have like define LCP, which is largest common prefix. And then we will have to implement class of finding the solution. Okay, the time is up, but I can do this in the next video. But this is like a pretty important solution because tries are very common and usually used in real world scenarios as well. For example, when you're trying to find a file in a directory and then you use command variable. Also, it's used in auto completion and spelling checker. And this can also go into like specialized try structures like Patricia try or something. So I don't know much about it, but I can definitely learn and like make a other video, not in this one though. But thanks for watching.